So the question is find the angles in radians and degrees between the hour hand and minute hand of a clock when the time is. So they have given five different timings. First one is 1 p.m. Second one is 2:25 p.m. Third one is 9:30 p.m. Fourth one is 5 hours 40 minutes. And the fifth one is 7:45 a.m. Let us write down the given data. So here they have given to find the angles between the hour hand and minute hand of a clock. So therefore we can write down that a clock is 360 degrees. That is, it is circular. Let us mark down 1 p.m. in our clock. So let this be our clock. And the time is 1 p.m. So the hour hand is at 1 and the minute hand is at 12. So they have asked us to find the angles between the hour hand and minute hand. So they have given angles here between the hour hand and the minute hand. There are two angles here. That is the exterior angle, that is the outer angle between the hour hand and minute hand, that is theta O, and the inner angle, that is the angle between the minute hand and the hour hand, that is theta I. So we all know that a clock measures 360 degrees. First, let us find out how long will the minute hand and the hour hand take to complete one full rotation in a clock. First, let us take the hour hand, that is this one. So let us say it is at 1, position 1, that is 1 p.m. So we have to find out how long will the hour hand take to come back to its initial position, that is 1 p.m. That is here, 1 p.m. That is how long will it take to complete 360 degrees. So we know that it will take 12 hours. In terms of minutes, it is time taken for the hour hand to complete one full rotation in a clock, that is 360 degrees. So it takes 12 hours. In terms of, let us write it down in terms of minutes. So 12 hours into 60 minutes. It gives us 720 minutes. So next, let us find out the rate of movement of the hour hand. So for that, we have to simply divide 360 degrees by the time taken for the minute hand to complete one full rotation in a clock, that is 720 minutes. So rate of rotation of our hand is, so a clock measures 360 degrees and the hour hand takes 720 minutes to complete one full rotation, that is 360 degrees. So when we divide 360 degrees by 720 minutes, we will get the rate of rotation of the hour hand. So 36 into 2 is 20, 36 into 2 is 72. So the hour hand moves 0.5 degrees per minute. So similarly for the minute hand. So in this example, say it is at 60 minutes here. So how long will this minute hand take to come back to its initial position, that is 60 minutes? So it takes 60 minutes. So let us write that down. That is, the minute hand takes 60 minutes to complete 360 degrees in a clock. So let us write that down. Time taken for minute hand to complete one full rotation in a clock, or to complete 360 degrees in a clock. So it takes 60 minutes. So next, in order to find out the rate of rotation of a minute hand, we have to divide 360 degrees by 60 minutes. So 60 minutes is the time taken for the minute hand to complete one full rotation in a clock. Therefore, rate of movement of minute hand is equal to 360 degrees divided by 60 minutes. So 0 and 0 cancel out each other. 6 into 6 is 36. So minute hand moves 6 degrees per minute. So now we have found out the rate of movement of the hour hand and the minute hand. Next, let us find out the location of our hour hand and minute hand. Find out the location of our hour hand and minute hand in minutes, and then multiply it by their respective rate of rotation per minute. We will get the location of our minute hand and hour hand at 1 p.m. Location. Let us find out the location of our hour hand. So location of our hand. So let that be theta h. So our hand is at 1 hour. So in terms of minutes, it is 60 minutes. So 60 minutes, and the rate of rotation of our hand is 0.5 degrees per minute. So when we multiply 60 minutes into 0.5 degrees per minute, we will get the angle of our hand. So minute unit and minute unit cancel out each other. 60 into 0.5 degrees gives us 30 degrees. So the location of our hand, that is theta h, is 30 degrees. Next, let us find the location of our minute hand. So location of minute hand, let that be theta m. So here in the question it is given it is at 0 minutes. Here we can see the minute hand is at position 12. So therefore we can say that our minute hand is at position 0 degrees. So it has not even moved 1 minute. So we can so 0 minutes. And the rate of rotation of our minute hand is 6 degrees per minute. 0 into 6 is 0. So minute unit cancel out each other. So we have 0 degrees. So next let us find out our inner angle, that is theta I. In order to find out that, so here in this from the obtained data, we can see here that our hour hand has moved further than our minute hand. So when we minus the highest degree, that is the location of our hour hand, from our lowest degree, that is the location of our minute hand, we can find the angle in between our minute hand and hour hand. That is theta h minus theta m, which is equal to the location of our hour hand is 30 degrees and our minute hand is at position 0 degrees. So the angle between the minute hand and the hour hand is 30 degrees. In terms of radians, we can use the same technique. That is, for all, pi radians is equal to 180 degrees. So how much is 30 degrees in radians? So let this be x. When we cross multiply this, we get x is equal to pi radians into 30 degrees divided by 180 degrees. 0 and 0 cancel out each other. Degree unit and degree unit cancel out each other. 3 into 6 is 18. So we get x is equal to pi by 6 radians. So next let us find out the outer angle. That is from here to here. Angle between the hour hand and minute hand. Theta O is, we know that a clock measures 360 degrees. So 360 degrees minus the inner angle gives us outer angle. So 360 degrees minus theta I, which is equal to 360 degrees minus 30 degrees, which is equal to 330 degrees. In terms of radians, we get 11 pi by 6 radians. Theta I in terms of degrees is 30 degrees, and in terms of radians it is pi by 6 radians. And outer angle theta O is 330 degrees. In terms of radians, it is 11 pi by 6 radians. And the next time given here is 2:25 p.m. So we have already found out the rate of movement of our hour hand and the rate of movement of our minute hand. So in the following questions, we simply have to multiply rate of movement of our hour hand and rate of movement of our minute hand to their respective locations of hour hand and minute hand, that is 2 hours and plus 25 minutes for hour hand, just 25 minutes for minute hand, to get the location of our hour hand and minute hand. After that we will be able to find the inner angle and the outer angle. So before doing that, let us mark the position of our time in our clock. So let this be your clock, and the time given in the question is 2:25 p.m. That is here. That is the hour hand, minute hand is here, and hour hand is at position 2. So our inner angle, that is the angle between the hour hand and minute hand, is theta I, and the angle between the minute hand and the hour hand is theta O, that is the outer angle. So when this question is asked for each and every time given, we have to write down the data, that is data, and calculate the rate of rotation of minute hand and hour hand. Then we have to locate the position of our minute hand and hour hand. So here I'll be writing down from the location of the hands, location of our hand, that is low, that is location of our hand, that is theta h is equal to, so here the time is 2 hours and 25 minutes. So our hand has moved 2 hours plus 25 minutes. In terms of minutes, it is equal to 2 into 60 minutes plus 25 minutes, which is equal to 120 plus 25 minutes, which is equal to 145 minutes. So our hand has traveled 145 minutes out of 720 minutes. So our rate of rotation of our hand is here, that is 0.5 degrees per minute. So when we multiply 145 degrees, 145 minutes into 0.5 degrees per minute, we can find the location of our hand. So minute unit and minute unit cancel out each other. We get 72.5 degrees. That is our theta h. Next, let us find out the location of our minute hand. That is theta m. So it has only moved 25 minutes. So 25 minutes into rate of rotation of our minute hand. Rate of rotation of our minute hand we have already found out here. That is 6 degrees per minute. So 25 minutes into 6 degrees per minute gives us the location of our minute hand, which is equal to 150 degrees. So this is the location of our minute hand. So next let us find out our inner angle, theta I. So here we have seen here that in the clock we can see here that the minute hand has moved farther than the hour hand. So therefore when we minus the location, when we minus the angle of our hand from the minute hand, we will get the angle between the hour hand and minute hand, that is theta I. So here in the previous question, that is theta h minus theta m, because here our hand has moved farther than the minute hand. So in the second question, the minute hand has moved farther than the hour hand. So therefore we will be minusing theta h from theta m. Theta m minus theta h, which is equal to 150 degrees minus 72.5 degrees, which is equal to 77.5 degrees. In terms of radians, if we follow the same technique, we will get, for all pi radians is equal to 180 degrees. So this 77.5 degrees can also be written as 77.5 degree. When we convert it into fraction, we get 154 plus 1 divided by 2 degrees, which is equal to 155 by 2 degrees, which will be easier to convert to radians. That is 155 divided by 2 degrees. Let this be x. When we cross multiply it, we get x is equal to pi radians into 155 divided by 2 degrees divided by 180 degrees. Degree unit and degree unit cancel out each other. So we get pi radians into 155 divided by 2 into 180. So we get 5 into 36 is 180. 5 into 3 is 15 and 5 remainder is 5. 5 into 5 is 1. So we get 31, which is equal to 31 pi by 72 radians. So next let us find out our outer angle, that is the angle between the minute hand and hour hand, that is theta O. We simply have to minus the inner angle from 360 degrees, that is 360 degrees minus 77.5 degrees, which is equal to 282.5 degrees. So in order to, when we try to find it in radians, it will be easier to convert when it is in fraction. So 282.5 can be written as 282 and half degree, which is equal to 564 plus 1 divided by 2 degrees, which is equal to 565 by 2 degrees. When we follow the previous technique, we get for all pi radians is equal to 180 degrees. So therefore, how much is 565 divided by 2 degrees in radians? Let this be x. When we cross multiply, we get x is equal to pi radians into 565 divided by 2 degrees divided by 180 degrees. Degree unit and degree unit cancel out each other. So we get pi radians into 565 divided by 2 into 180. So 5 into 36 is 180. 5 into 5 is 1. 5 into 5 is 1. 5 remainder is 15. So 5 into 3 is 15. So we get 113 pi by 72 radians. So therefore, our final answer is theta I, that is inner angle, is equal to 77.5 degrees, and in terms of radians, it is 31 pi by 72 radians. And our outer angle, that is theta O, is 282.5 degrees in terms of radians, that is 113 pi by 72 radians. So the next time given here is 9:30 p.m. So you can pause the video and try to solve the problem by yourself, and come back and check the answers. So the third time given here is 9:30 p.m. We have already marked the time in our clock, that is 9:30 p.m. First, let us find out the location of our hour hand. So location of our hand, that is theta h. So our hand has moved 9 hours plus 30 minutes. In terms of minutes, it is 9 hours into 60 minutes plus 30 minutes, which is equal to 540 plus 30 minutes, which is equal to 570 minutes. Our hand has moved 570 minutes. So, and the rate of rotation of our hand is zero point 0.5 degrees per minute. So, when we multiply 570 minutes into zero point 0.5 degrees per minute, we will find the location of our hand. So, minute unit and minute unit cancel out each other. So, we get theta h as 285 degrees. So, similarly for minute hand, location of minute hand. So minute hand has moved only 30 minutes. So theta m is equal to 30 minutes, and rate of rotation of our minute hand, that is 6 degrees per minute, which is here. So 6 degrees per minute unit and minute unit cancel out each other. We get 180 degrees. Theta m is equal to 180 degrees, which we can actually see in this figure that minute hand is exactly opposite to 12, the position 12, that is 60 minutes. So therefore it makes straight line, which is equal to 180 degrees. Inner angle, that is theta I. So here we can see that the hour hand has moved farther than the minute hand. When we consider 12, that is 60 minutes, or 12 hours as our starting position. When we consider this, our hand has moved farther than the minute hand. So we have to minus the location of the minute hand from the hour hand. Theta I is equal to theta h minus theta m, which is equal to 285 degrees minus 180 degrees. 105 degrees. In terms of radians, for all pi radians is equal to 180 degrees. So how much is 105 degrees in radians? Let this be x. When we cross multiply this, we get x is equal to pi radians into 105 degrees divided by 180 degrees. Degree unit and degree unit cancel out each other. 5 into 36 is 180. 5 into 2 is 10, and remainder is 1. So 5 into 1 is 1. So 3 into 7 is 21, and 3 into 12 is 36. So we get 7 pi by 12 radians. So next, in order to find outer angle, when we minus the inner angle from 360 degrees, that is the full circular measure of a clock, we will get the outer angle. Therefore, 360 degrees minus 105 degrees, which is equal to 255 degrees. In terms of radians for all, pi radians is equal to 180 degrees. So how much is 255 degrees in radians? Let this be x. So we get x is equal to pi radians into 255 degrees divided by 180 degrees. Degree unit and degree unit cancel out each other. We get 36. 5 into 36 is 180 degrees. 5 into 5 is 25. Remainder is 5. 5 into 1 is 5. So 3 into 12 is 36. 3 into 1 is 3. So remainder is 2. So 21. 3 into 7 is 21. So we get 17 pi by 12 radians. So therefore, our answer is theta I, which is equal to 105 degrees. In terms of radians, it is 7 pi by 12 radians. Outer angle theta O is equal to 255 degrees, which is equal to 17 pi by 12 in radians. Fourth time given here is 5 hours 40 minutes. Since we have found out the rate of rotation of our hour hand and rate of rotation of our minute hand previously, that is 0.5 degrees per minute and 6 degrees per minute, we can directly find the location of minute hand and hour hand and find the inner angle and outer angle. So before that, mark the time in our clock, that is 5 hours and 40 minutes. So this is 5 hours and 40 minutes. So this is our inner angle, that is the angle between the hour hand and minute hand, that is theta I. The angle between the minute hand and the hour hand is theta O. So next let us find our location of our hour hand, that is theta H. Our hand has moved 5 hours plus 40 minutes. In terms of minutes, it is 5 into 60 minutes plus 40 minutes, which is equal to 340 minutes. And the rate of rotation of our hand is 0.5 degrees per minute. So our hand has moved 340 minutes and the rate of rotation of our hour hand is 0.5 degrees per minute. So when I multiply the rate of rotation of our hour hand into the time, how many minutes the hour hand has moved, we can find the location of our hour hand, which is equal to 170 degrees. So next let us find the location of our minute hand. Minute hand has only moved 40 minutes. Therefore 40 minutes into rate of rotation of our minute hand, which is 6 degrees per minute, which is already given here, which we have found out already here, is equal to 240 degrees. So minute unit and minute unit cancel out each other. Therefore, our inner angle, that is theta I, is equal to minute hand has moved farther than the hour hand. Therefore, we have to minus the position of hour hand from minute hand to find the inner angle, that is theta I. Therefore, theta M minus theta H gives us the angle between the hour hand and minute hand, which is equal to 240 degrees minus 170 degrees, which is equal to 70 degrees. In terms of radians, it's as usual for all pi radians is equal to 180 degrees. Therefore, 70 degrees in radians is how much? Let this be x. When we cross multiply this, we get x is equal to pi radians into 70 degrees divided by 180 degrees. Degree unit and degree unit cancel out each other. 0 and 0 cancel out each other. So we get 7 pi by 18 radians. So next the outer angle. Outer angle theta O is simply you have to minus the inner angle from 360 degrees. So that is 360 degrees minus theta I, which is equal to 360 degrees minus 70 degrees, which is equal to 290 degrees. In terms of radians, for all pi radians is equal to 180 degrees. So how much is 290 degrees in radians? Let this be x. When we cross multiply this, we get x is equal to pi radians into 290 degrees divided by 180 degrees. 0 and 0 cancel out each other. Degree unit and degree unit cancel out each other. So we get 29 pi by 18 radians. Therefore, the answer for this question, that is 5 hours 40 minutes, is theta I, which is equal to 70 degrees. In terms of radians, it is equal to 7 pi by 18 radians. The outer angle theta O, which is equal to 290 degrees. In terms of radians, it is equal to 29 pi by 18 radians. And the last time, or the question given here, is 7:45 a.m. So you can pause the video and try to find out the answer. Here I will be finding only the theta h, theta m, theta I and theta o, because previously we have already found out the rate of rotation of our hour hand and rate of rotation of our minute hand. So first let us mark the time in our clock. 12. So 7:45 a.m. So the angle between the hour hand and minute hand is this one, which is the inner angle. The angle between the minute hand and hour hand is theta O. So first let us find out the location of our hour hand, that is theta H. So our hand has moved 7 hours and 45 minutes. That is 7 hours into 60 minutes plus 45 minutes, which is equal to 420 plus 45 minutes, which is equal to 465 minutes, and the rate of rotation of our hour hand is 0.5 degrees per minute. Minute unit and minute unit cancel out each other. Theta h is equal to 232.5 degrees. Next, the location of our minute hand, that is theta m. So the minute hand has moved 45 minutes, and rate of rotation of a minute hand is 6 degrees per minute. So minute unit and minute unit cancel out each other. So we get theta m as equal to 270 degrees. Inner angle theta I, that is, so here we can see that minute hand has moved farther. So when we minus location of hour hand from minute hand, we can find the location between them, that is the location between the hour hand and minute hand. So therefore theta m minus theta h is equal to 270 degrees minus 232.5 degrees, which is equal to 37.5 degrees. In order to find in radians, let us convert this into fraction, that is 37.5 degree, which is equal to 74 plus 1 by 2 degrees, which is equal to 75 by 2 whole degrees. So therefore, for all, if pi radians is equal to 180 degrees, so how much is 75 by 2 degrees in radians? Let this be x. When we cross multiply this, we get x is equal to pi radians into 75 by 2 degrees divided by 180 degrees. Degree unit and degree unit cancel out each other, so we get pi radians into 75 divided by 2 into 180 degrees. 180. So 5 into 36 is 180, 5 into 15 is 75, 3 into 5 is 15, 3 into 5 is 15, and 3 into 12 is 36. Therefore we get 5 pi by 24 radians. Next is our outer angle, that is theta O. When we minus the inner angle from 360 degrees, we get our outer angle, that is 360 degrees minus theta I, which is equal to 360 degrees minus 37.5 degrees, which is equal to 322.5 degrees. In order to convert it to radians, let us convert this into fraction. 322.5 degrees, which is equal to 640, which is equal to 644 plus 1 divided by 2 degrees, which is equal to 645 by 2 degrees. So therefore, for all pi radians is equal to 180 degrees. So therefore, how much is 645 by 2 degrees in radians? When I cross multiply this, I get pi radians into 645 divided by 2 degrees divided by 180 degrees. Degree unit and degree unit cancel out each other, is equal to pi radians into 645 divided by 2 into 180. So 5 into 36 is 180 and 5 into 129 is 645. 3 into 12 is 36. 3 into 43 is 39. 3 into 43 is 129. So, which is equal to 43 pi by 24 radians. So, therefore, our final answer is theta I. In terms of degrees, it is 37.5 degrees. In terms of radians, it is 5 pi by 24 radians. Next, our outer angle theta O, which is equal to 322.5 degrees, and in terms of radians it is 43 pi by 24 radians. Hope you got your answers correct. Thank you.